We're going to moving on to graphing the unit circle on a flat graph. Much like when you look at the pictures in your geography books of the world. It's a flattened version of the world. You have the globe, and then they unwrap the globe. So a sine wave. Notice here there's a point, and that point is simply recording the height. Get it? Sine is the y value, is the height. And this height right here is being mirrored over here. And we know as we go higher and higher and higher, we reach the highest point of our sine wave, thus our highest point. Then we start to come down as the sun sets, the Greeks saw, and then the sun is on the other side of the world, reaching noon or midnight, depending on which side you are on, and then it comes back to the beginning. Yay! We can see the same with the cosine wave, except the cosine wave is measuring this distance along the x-axis. So you can see as we move, this distance along the x-axis is getting smaller. So this dot is moving down, representing the distance getting smaller, till that when we are perfectly at noon, there is no shadow on the ground. That's what the Greeks noticed. There's no shadow at noon, so therefore there's no distance along the x-axis, and then the shadows get longer as it becomes nighttime, until once again I get smaller and smaller, and back. So there you are. There you have it in a nutshell. So remember, I say this: a sine wave is a hill followed by a valley, and a cosine wave is just a big valley. If you really, really want to boil it down, this looks like the letter C for cosine. And this looks like the letter S for sine. Just making it as simple as possible. We have some words we need to understand. A sine wave and a cosine wave have this formula. Y equals A, and then here can be the word sine or the word cosine, B, x plus c plus d. And you're going to need to learn what each one of these letters mean. So we're going to go slowly today. First thing, the word period. How long it takes to make one complete wave. Well, as far as you know right now, a sine wave takes 2 pi to make one complete wave. A frequency. How many complete waves you can make in 2 pi? Well, I'll tell you this, in high school I used to get confused between period and frequency. I could never tell the difference. And then I thought about it. High school, get it? We have one period. How long does one period take? Well, at Pearson, one period takes about 43 minutes. Frequency, how many complete waves you can make in 2 pi? Oh, how many periods are there in a day? There's 10 periods in a day at Pearson. So that's how I could keep the definitions straight in my head. Amplitude, the maximum value of sine or cosine wave hits minus the minimum value. Now, where does this little formula come into play? Well, the amplitude is this A value right here. So the amplitude is the A value when we write the equation of a sine or cosine wave. We'll see that in our next example. Frequency. The frequency is also hidden in this. So when y equals A sine B x plus c plus d, this B right here is the frequency. If you look at that letter, it'll tell you how many waves you can make in 2 pi. And period is a formula. Period is found by taking 2 pi and dividing it by b, your frequency. So take the time to make sure you've got this all down. And right now your head's probably spinning going, what are you talking about? Well, remember back in the 8th grade when we talked about mama and baby functions? We're about to do some more mama and baby functions. So right now what you have in front of you is mama. This is mama sine wave. And we are going to graph her baby, which is 2 sine x. All right, so let's get some things straight about mama. Remember, we have this general equation. Y equals a sine b x plus c plus d. Amplitude. Amplitude was max minus min divided by 2 in absolute value. Well, this we're going to denote as 1. I just made it bigger so you could see it. So the amplitude for a regular mama is 1. You can see right here, there's a 1 in front. You could get that by doing 1 minus a minus 1 over 2, which equals 2 over 2, which equals 1. Period. Period is how long it takes to make one sine wave. Well, how long did it take to make a hill followed by a valley? It took 2 pi. Frequency. How many sine waves do I see in 2 pi? Well, I see 1. 1 hill followed by 1 valley. That's 1. Just for giggles, the domain is all reals, and the range is from a low of -1 to a high of 1. So now they want me to do baby. We're going to do baby in blue. Baby is y equals 2 sine x. Well, the amplitude is 2. Its period, well, that's how many you see in 2 pi. So I'm going to look at its frequency first. Its frequency should be right there. What's that number that we see there? 1. Oh, that's telling me there's 1 sine wave in 360 or 2 pi. Oh, so that means its period is also 2 pi. Its domain is all reals, but its range, because its amplitude is different, is from -2 to 2. So if I were to graph baby, baby looks just like mama, but it's taller because it says I'm doubling mama. So instead of going to 1, I'm going up to 2. And instead of going to -1, I'm going down to -2. Everything else, well, if I double 0, it's 0. If I double 0, it's 0. If I double 0, it's 0. So this is what that baby looks like. And again, it would go backwards the same way because it's secular. Whoops. A page moved. And I'm not the greatest at drawing on the pad, but you get the idea. We're going to look at a cosine wave now. So here we have mama. Mama is simple, cosine. She's a giant valley. But baby over here, baby's got a lot going on. Baby only wants to be half as high. We've got a 2 in front of our x. In addition, we've got a negative. All right, so cosine wave, mama in pink, it's got an amplitude of 1, because there's a 1 out front. I've got a period of 2 pi, takes me 360 degrees. I've got a frequency of 1, I've got a domain of all reals, and I got a range that goes from -1 to 1. So what about baby here? Baby, first off, I'm going to start with its amplitude. Its amplitude is 1/2, not -1/2. Amplitude, remember, had an absolute value sign, so all amplitudes are positive. Frequency, I'm going to jump down to frequency. Remember, frequency is this number right here. So it's telling me there are 2 cosine waves stuck between 0 and 360. Well, if I need to fit 2 cosine waves in there, then the period must be pi. Because if one of them can fit in 2 pi, when I try and fit 2 into 2 pi, I've got to squish them in there. Its domain is all reals, and its range is from -1/2 to +1/2. Whoops. So how do I do that? This is what I do. I just graph from 0 to pi. I've got to fit a cosine wave in there. So that means it's got to get squished into there. Now, not only does it have to get squished into there, it's telling me also that its amplitude isn't as high. It only goes 1/2. So if this was 1, and this is -1, 1/2 high would be right here. So then I'd have to end right here also, directly in between. I hit my low, and that's what a 1/2 cosine 2x would look like. But now it's negative. So negative means I negate everything. So instead of a +1, this is really going to be negative. It's going to be backwards. So instead, this is going to be down here, this is going to be up there, and this is going to be down there. And voila, you just drew baby. If I kept it going, it would look like that. Its range is from -1/2 to +1/2. Frequency, I see 2 cosine waves, 1, 2. Period is pi. It takes pi degrees to make 1, and its amplitude is 1/2. So summary. We're going to do a lot of these tomorrow in class as practice. What I want you to realize is that we've got mama wave. Mama is a hill followed by a valley. Her domain is all real numbers, and her range is from -1 to 1. Cosine is just a big valley. Her domain is all reals, and her range is also -1 to 1. Now you may be thinking, Mrs. Trulin, you just told me the general formula is A, sine or cosine, B, but you didn't tell me what x plus c and this plus d meant. Little by little, let's just practice graphing some sine and cosine waves tomorrow.